Hi gentlemen, and welcome back to class 6. We are going to be continuing with implicit differentiation today. However, today we're going to go beyond just finding the first and the second derivative, and we're going to start answering questions actually using that information. We'll be looking for equations for horizontal and vertical tangents and determining whether those points are a maximum or a minimum. Recall, just as some review here, okay, when we're dealing with horizontal tangents, that means that whatever our curve is, so it could be something that looks like this, your tangent line is going to be horizontal. Recall that that means that your slope is going to equal to 0 at that specific coordinate. In addition to that, recall now that we have equations that aren't necessarily functions, we can also have vertical tangents. Vertical tangents means at the point we have there, the tangent line to the graph is going to actually be vertical. The slope for a vertical line is undefined, or we can say that it has no slope. Remember, when we have horizontal lines, or the horizontal tangents, those come in the form of y equals to some number. Also recall, when we have vertical lines, okay, vertical lines come in the form of x equals to some number. That information is actually going to be really important as we go through. Let's look at the first example for today. The first example says, consider the curve defined by 2y to the third plus 6x squared y minus 12x squared plus 6y equals 1. If you're going to continue taking calculus next year, you might get an AP question that looks exactly like this. Note, the first question is just to show that the first derivative is equal to 4x minus 2xy divided by x squared plus y squared is 1. Sometimes they'll give you an equation and they'll just say, show that this is the derivative. So if we start with our equation here, 2y to the third plus 6x squared y minus 12x squared plus 6y equals to 1, we will not solve for y, just like we did last week, but we'll continue just differentiating as it is. So we'll take the derivative of our first term, that will be 6y squared. Don't forget that this term here is a y, so therefore we're going to need our chain rule for a y, so it'll be times dy dx. If we take a look at our next term, recall that this is a product, so we're going to have to use our product rule. We will have our first function times the derivative of the second. The derivative of y will be dy dx. Note that there was no chain rule for the x squared because x is a function of x. So remember that dx that we had last time? We don't need that here. So far we have the first times derivative of the second plus the second times derivative of the first, so times 12x. We're going to continue on to our next term here. So we have minus 24x. Notice again, there's no y, so we don't need a chain rule. And then we have plus 6 dy dx. Notice there's an x here, there's a y here, so we have to use our chain rule, equals to 0. Recall, we're going to move all our terms with dy dx on one side and move the remaining terms on the other side. So here we have 6y squared dy dx plus 6x squared dy dx. Notice this term here does not have a dy dx, so we're going to move it to the other side by subtracting 12xy and subtracting 12xy. So we will have on this side here negative 12xy. In addition to our next term, that minus 24x, we're going to add that to the other side also. So plus 24x and plus 24x. Notice the plus 6 dy dx is going to stay on that side also. Okay, now that we have here, okay, our derivative in terms of x's and y's with all the dy dx's on one side, just going to move it down to make it a little bit more clear for you. Okay. We're going to factor out our dy dx. So we have dy dx is equal to, not equal to yet, 6y squared plus 6x squared plus 6 equals to negative 12xy plus 24x. All we need to do is divide by that 6y squared plus 6x squared plus 6. Do the same to the other side. 6y squared plus 6x squared plus 6. And we're just going to simplify that expression there and wind up with dy dx is equal to negative 12xy plus 24x all over 6y squared plus 6x squared plus 6. Note all the terms here have a factor of 6, so we can reduce every single term by 6. Notice on top also that this is a minus or a negative term, and this is a positive term. So as we're reducing everything by 6, I'm just going to flip around the top there. So 24 divided by 6 is 4x. 12 divided by 6 is minus 2xy. And then we have that all over y squared plus x squared plus 6. Exactly what we have above. Remember, addition is commutative, so if you'd like to, you can actually change these back and forth just to put them in that proper order. That's the first part of that question.